In this video, we want to look at how to calculate the limit of this function. To start with, we normally need to plug in x equal to 0 to the original function and see what we get. When we plug in 0, we would get tangent 0 over sine 0. Here we have a 0 over 0, and the answer for that is not determined at the moment. So that's why it's called a indeterminate form. And when we see an indeterminate form, we want to think about using the L'Hopital's rule. The rule states that the limit of our original function would be the same as if we take derivative of the top and bottom function. So let me just write our original equation here. So what we want to do is we want to take the derivative of the top and bottom function separately. Remember, in here you don't need the quotient rule. You want to take the derivative for the numerator and the denominator separately. Okay, so what's the derivative of tangent 3x? We know the tangent x, the derivative of that is equal to secant x squared. In here, because we have a 3x inside, therefore we need to use the chain rule, which gives us the secant 3x squared times the derivative of the inner function, which is the derivative of 3x, and then times 3. The derivative of bottom, we have sine 2x. We know the derivative of sine x would be cosine x. Therefore, we need to use the chain rule again, which the derivative of sine 2x give us cosine 2x, then times the derivative of the inner function. The derivative of 2x is 2, so let's times 2 here. Okay, so now we have our new function. Let's calculate what it would be when x goes to 0. We would have secant 0 squared times 3 over cosine 0 times 2. And we know secant 0 is equal to 1. 1 times 3 is 3. And on the bottom we have cosine 0 is equal to 1. 1 times 2 is 2. So therefore, the answer for this question is 3 over 2. This is a good example of how L'Hopital's rule can help us solve an indeterminate form of a limit question.